Okay, our next talk is about Starkpilled with Starknet. Yeah, our speaker is Chyuan from the Starknet Foundation. Is going to be as ambassador from the Starknet Foundation. Is going to be explaining a bit more. So for those of you interested in Starknet, this is the place to be. All right, let's give him a big warm round of applause as we welcome Chyuan to the stage to share a little bit more with us, a little bit more about Starknet. All right. You can take out the mic also if you want to walk around. Yeah, just take out the mic as well.
Like that?
Yeah, that's fine.
Oh, okay, it works. Cool.
Okay, go ahead. The stage is yours, bro.
Wait, let me give it a try. Okay, cool. Yeah, it works. Hi, everyone. Thank you so much, Ross, for the introduction. My name is Chyuan, Chee, or whatever, convenient for you to mention. I represent the Starknet Foundation. I'm an ambassador at the Starknet Foundation. If you see me running around, that's because today I'm also an organizer for the event, and I'm so happy that I see all of you guys here listening attentively, coming all the way from all parts around the world, coming to Malaysia to enjoy ETHKL. Thank you so much for coming. And I also work for Nethermind as a developer. So I got a couple of hats, but today my role is I'm an ambassador for Starknet Foundation. So my topic, Starkpilled with Starknet. So basically, Starkpilled means that I'm trying to give you like the tablet, the pill, the medicine, to get you, how can I, Starkify you, like to make you involved in the world of Starknet. So hopefully at the end of the talk, you always hit me up. So first of all, let me give you a motivation as to what my talk is about and why do we need Starknet. So what is the state of Ethereum now? So over here, I took a screenshot of the blocks that has been produced on mainnet. This is an ETHKL block explorer website. Obviously, if you want to check your blocks, that's where you go. And what I'm trying to say is that we notice that the block production is consistently at 12 seconds per block. And we roughly see around like 140-ish transactions in 12 seconds. If you try to do some math, it turns out to be around like 11 to 12 TPS. And the gas price is around 70 Gwei. I've checked that and I just put it here to make it convenient. So if we were to ask the question is, how do we make blockchain in such a way that it scales? How do we make blockchain in such a way that it reaches infinite amount of people in line with the infinite garden concept? 12 TPS, which is 12 transactions per second, this doesn't make it. This doesn't make sense, right? We need to achieve like 1,000 TPS. Like even if everyone is using it on a constant basis, like 1 million TPS, so on and so forth. So this is a problem that we are facing today. Yes, and one thing I want to stress that if you were to perform like a simple swap on Uniswap, like if you easily could spend like $25-ish, $23. If you want to pay your friends, return your friends the money that he or she spent on coffee, which is like $3, but you're paying $7, $6 for a simple USDT transfer. So your transfer is basically more expensive than 2 cups of your coffee. So what does it mean? It means that it doesn't make sense for you to perform simple, easy transactions on the mainnet anymore. So what I'm trying to draw attention to is that Ethereum nowadays, it works. It is doing what it's supposed to do, but it's not enough. Right? It's not enough to reach what we want. We want 1 million people to use. We want a billion users to use. We want 1 million transactions per second, so on and so forth. So the state of Ethereum right now, TLDR, it's not good enough. And Starknet aims to improve that, and we'll see how it goes. Let me quickly explain like why is this happening. So in a typical layer 1, like in Ethereum, for example, what happens is that everyone creates a transaction, sends it to a mempool, and the block producer will then validate the block. And what happens is that every single node in the space will then re-execute the block to validate to see if the outcome of the transactions in the block are correct. So that means everyone's doing the check. So what it means is that even though like I produce the block, like all of you are like participants in the blockchain, 1, 2, 3, 4, 5, like 20, 30 of you, we need to re-execute the same thing over and over again. We can think of this as like we're just repeating the work that your friend is doing, and he's repeating the work of his friend is doing, her friend is doing, blah, blah, whatever, so on and so forth. And this is a problem that this is something that has to be done to make sure that it's valid, but it's also a problem because you're wasting a lot of resources. And that limits how much TPS can go in the network, right? Because not everyone can have a good enough machine to execute like billions and thousands of millions of transactions with a simple Mac, for example. You can't do that because it's too expensive for exhaustive, so to say. So there are a couple of solutions. Let me introduce you one of the solutions that people has used. So solution number one, another faster L1 chain. Not going to name names here, but we have seen a couple of so-called faster L1 chains that appear like, oh, we scale Ethereum, we are faster, we are cheaper. This is their claim, right? So what they're actually doing is that they sacrifice on this thing, this very important factor called decentralization, which is what blockchain is preaching about since day one. They how can I say, they gatekeep, not the gatekeep, they price out users who are not able to afford expensive machines, because and in exchange they are the ones that are running expensive machines gets to run like the million transactions. So let's say I have the funds to run like a 1 terabyte RAM machine, but probably he or she doesn't have the resource, then he or she cannot participate in the network because you simply do not have the enough computation power to be a part of the network, and that is something that is a huge sacrifice. So at the end of the day, we can think of like, we are pretty much going back to a centralized system. There's no point of having blockchain if we were to do that, right? The Web2 world works, bank transaction rarely fails. So if we were to do it, to some point, like, why are we even talking about decentralization, and why are we even talking about blockchain in the first place, right? So the second approach that people has come up with, which already been done, it's what we call the optimistic approach. So what happens is that one single party will run this very heavy execution, but only one. What this person do is that the person will send the data to layer one. And optimistically, that means you do not verify yet, but you trust that the execution is done correctly. And what everyone can do in the ecosystem is that you can run this thing called fraud prover. So you are going to always monitor the chain, and you're always going to like be like a fisherman trying to fish out like, oh, if any transactions that are made by this so-called sequencer, it's malicious or not. If it's so, you're able to then engage this thing called a fraud proof, or this fraud challenge. You're able to challenge the sequencer in a back and forth manner, saying, hey, you have done something wrong. If you are, then you are slashed, and so on and so forth. So the good thing about this is that, okay, sure, you only need one person to run this heavy execution, and you only need one person to perform this so-called fisherman activity in a very correctly. So you only trust one out of many people. But at the end of the day, we're going to ask, like, okay, everyone is assuming that if only one person is running it, like, who's going to run it at the end, right? Like, if I'm not going to run it, are you going to run it? Probably not. Like, because running the fisherman thing could take a bit of resource. Like, what is my motivation? What is my incentive in running it? So this works, and it's mainly backed by this thing called game theory. So it works. It's working right now. It's the good examples are Optimism and Arbitrum. They are working very well. This is another solution that people have proposed. The third solution is what we call the validity rollup approach, where, again, similar to the optimistic approach over here, one single party will do all the execution, and the data that is being executed will then be published on the layer one chain, similar to how the first approach, the second approach was. And in addition to publishing the data, you also publish this thing called the proof. So you're proving that the the state changes are being done correctly. So thereby eliminating the need of a fisherman having to always monitor the activity of the chain. So when the proof is generated and when the proof is verified, you are assured that there's no one that can, like, there was no cheating, no malicious activity, no foul play was involved in generating the data on the state changes on L2. And this is based on mathematical proof. And in Starknet, in the example, we use Stark proofs. There are various couple of options, and there's a ZK track tomorrow for those who are interested. Highly encourage you to go and ask questions over there. There's a panel as well. But today we are going to talk about Starknet and Stark proofs. So as a result, what happens, right? Like, this is already live. It happened like a couple of, I don't know, I forgot when, like last month or something like that. We have seen like a massive spike in TPS. So that means we have achieved like 122 max TPS already. Doesn't mean that this is our limit. It only means that this is the limit of the users. Users are not using enough. Like, if there are more users, it could go even higher. But this is the limit of users. Doesn't mean that Starknet can only go to 126 TPS. No, it doesn't mean that way. It means that we need more users on Starknet so that we can push the boundary. Probably 1,000, 2,000. We'll see. Yes, so this is the result of doing the second approach. Third approach. One thing I would like to talk about Starknet, which I feel that is very innovative among even the L2 space, is we have this thing called a native account abstraction. So we have heard of this thing called 4337 account abstraction using our mempool. Has been going around. People are talking about like gas abstraction. You don't have to pay get native fee, blah blah blah, whatever. That means that if the validators are not doing that, that means you will need to wait for another block to possibly get our transactions included. What native abstraction does is that without every single transaction, it's an account by default, and every single block will definitely read from this so-called mempool that accepts account abstraction. What happens? A quick introduction is that what happens is that in the traditional world, we are used to having a private key being associated to a public key or address. In the account abstraction world, you have one address. You have every single account is a contract, and your so-called public verifying key or public key is being stored on the contract in this. And then what the sequences will do? The sequence is going to run this entry point contract that will then call the verify plus execution transaction in one step. So if your verification fails, your execution fails by default. So that means the verification stage is where you check make sure that your signatures are being done correctly for the transaction. So I mentioned verification as execution stage because they are very important. In these two different stages, you can play around, you can implement new cool stuff to it. And over here, I list out 3 very, very cool use cases that have been implemented by a couple of people. On the verification stage is where you're able to play around with your so-called private key. You're able to change your private key, but you are able to reuse the same account, right? So imagine like if I were to lose my private key in the Ethereum world, I would essentially lose all my funds that's associated with private key in a EOA wallet. But when it comes to an account contract, what you can do is that if you have set up your smart contract to accept this called account recovery mechanism, you can probably change your password or even forget password. It depends on how you want to implement it, and you're able to then retrieve or recover your funds that is logged onto that account. So these are one of the things that you can play around with the verification stage, because that's the stage where you check for the address, and you can be a bit creative there. You can even implement like a multi-sig algorithm to check for multiple signatures. Make sure that you can then execute a transaction even multiple signatures, so on and so forth. So it's up to imagination as to what you can do in this stage, right? And then you have this, then after the verification stage, you will then call the entry point contract, will then all call to the execution stage. And let me remind you of the current status quo as to how it looks like when you're trying to make a swap on Uniswap v3 on mainnet. So typically for a new token, if you are trading between 2 new tokens, what you're going to do is you're going to approve like multiple times, like approve here, and then finally you approve swap, like so 3 steps. If you have multi-call, probably if it supports multi-call, maybe 2 steps, 1 step. But with account abstraction, the execution stage, it supports multi-call by default. So everything is going to be just 1 step. You can approve, swap, and unapprove, right? Everything in 1 step without having to like, click, wait to get mine, then you click again. Like maybe you guys are used to it, but that is not acceptable should we want to onboard like millions of users, right? Like we are used to this very quick grab thing, like swipe and you pay thing. We want that we want to see that on the blockchain space, right? So yes, this is one thing that I really want to stress out. Multi-calls are something that is so underrated, so overlooked, and people just take it for granted. At least I did. And this is how basically multi-call looks like. Like you can see that this is a block explorer on Starknet. It's Voyager, the team that I'm working for in Dynamite. A bit of Chyuan there. So in the same transaction, you can see that there are multiple calls, and these are happening on the same transaction. So in the Ethereum space, you can only make 1 function call, but because of multi-call on Starknet, you can make multiple function calls. You can make 2, 3 calls, 5, 6, 7 calls. As long as you have the gas to pay for it, you're good to go. And that's basically about Starknet. Like Starknet has net account abstraction, we go through the motivation of why we need Starknet to scale blockchain, and account abstraction is cool. And I would like to introduce you to something that is very unique to Starknet. Cairo. Cairo is a smart contract language on Starknet. First up, a quick meme here. Like you may be wondering, for those who are like, why do I need to learn a new language? And for those who have seen Starknet, you probably have seen it change over the months. It's not a year, over the months. And Elias over there is like smiling over the months. So yes, why do you need to learn a new language? It's because Cairo is created from scratch, right? So that you're able to then create proof from the execution trace in a very efficient way. So what I'm trying to say is that unlike the traditional Solidity and the ZK event approach, to make the proof generation very efficient, the Starkware team rewrote the entire language just so that the proof generation is very efficient. So Cairo is built to generate proofs. And you can then go on to write advanced machine learning models in a very intuitive way using Cairo. And I mentioned Kakarot ZK VM over here because they are great. They are one of the great examples of the usage of Cairo. They wrote the entire ZK VM stack using Cairo. And the new Cairo syntax, Rust-like, very expressive, very explicit, very readable. As if you like Rust, you like Cairo. Yes. And I want to remind everyone that Cairo is a general programming language. And on a subset of Cairo will be the smart contract on Starknet. So using the same concept, the same language, but a different library, you can import different libraries for a smart contract. You're then able to deploy your contract on Starknet. But not to be mistaken, you can also write general programming language such as ZKVM, such as an AI model using Cairo. As long as you want to make sure that your execution is provable, Cairo is probably something for you. So how it works is that Cairo, in this step, will then do the execution and then generate the proof. This is a very hard step, right? And then you send proof over to in a very small, light computer, and then you just have to verify the correctness of the execution. So Cairo over here is able to then transpile your code, compile your code down to proofs. And then the proofs, you just verify the output in a very lightweight computer, and there you go. You don't have to re-execute it. So this is simply basically the concept of me sending proofs, and you just verify it to ensure that the state change is correct. So what are the alternatives to that, right? One of the examples we have is Circom. For those who are writing ZK circuits, Circom is also trying to do the same thing. You're trying to prove the execution is correct. But Circom is, you have to kind of change your mental model in writing Circom. It's not like the language that we're used to. You have to represent all your logic in circuit. You have to make sure that you constrain your circuits for soundness. If not, there's a potential exploit on your circuit. And it looks like this. It looks very different from your TypeScript, your JavaScript, your whatever Python that you're used to and love. It looks very different. Like basically, you have to learn a new language entirely. You have to change the way you think, and I think it's very hard compared to learning Cairo, to be honest. Because Cairo is like you don't have to change that much. Learn new syntax, but Circom you have to like kind of change the entire mental model. So there you go. Other alternatives like Hello 2. Hello 2, it's basically do not have a DSL. You still need to learn Rust to use the library of Hello 2. It's another beast. Sure, it achieves great things. You have recursions, but use it. You need to you need to learn how to write circuits as well. And even worse, you need to know what API from the library to call. So what I'm trying to say is that Cairo is a very simple way to prove your execution by writing the code that we are already used to. So high-level overview of what Cairo to proof looks like. First, we have Cairo, and then we compile down this thing called Cairo assembly, and or we call CASM, C-A-S-M. And from CASM, we will compile down to add traces. Add traces basically describes the execution in numbers. So we have this long trace that are felts, a few elements, and that is basically describes the behavior of our program. And from add traces, we will then convert to polynomials. And from polynomials, we'll then create a start proof out of the polynomial. So basically, this is like a very high-level overview of how you convert your code to proof. And I want to stress that for those who are afraid of touching Starknet because you're afraid, it's very hard to use, dev tooling is not that great, we have Remix. So Remix is where I learned my Solidity from back in the days when I want to deploy a contract to Ethereum Ethereum blockchain. We have also Remix on Starknet now, developed by my team, Nethermind team. It's very easy to use. I encourage for you guys to try it on yourself. There's even a remote local version for deploy and interact with it, so you don't even have to pay gas. There's Starknet Foundry. For those who likes the Foundry version for Solidity, and there's an equivalent version for Starknet as well. So again, the tooling that you love and often use in writing smart contracts on Solidity, it's already here on Starknet as well. There's Open Zeppelin. Like, how many of you use Open Zeppelin and say that my contract is safe? I'm one. So we have also Open Zeppelin on Starknet now. So there you go. You can mix and match your library templates, and then you can write safe, secure contracts. And there's Explorer. This is one Explorer that I'm working on. Probably I'm showing my own page. We love EtherScan, and we use EtherScan a lot. We also use Voyager a lot in Starknet. Obviously, there are others, but I'm going to mention Voyager for now. So you may ask, like, what's coming up on the Starknet world? We have Volition. Volition is a way to select which data availability layer you want to use. So if you feel that pushing your data to layer 1 is a bit more expensive, there's an option in the future to allow you to push to a certain data availability community. But this is something that is very, very, how can I say, premature. So we'll see it come, but it's not going to be that soon, but that's somewhere in the roadmaps. And that's going to fee marketplace. And there's going to be the concept of layer 3s. That's why we have things like Mandara, open source project. We want to encourage people to deploy Starknet on Starknet so you can then scale or even customize your own layer 3 on Starknet. Gas abstraction for native account is on the roadmaps. It's something I didn't mention. It allows you to pay fees without having native tokens on your wallet. So maybe you can assign like a paymaster to pay for you. So gas abstraction in the roadmaps. And the most important thing, people have been asking, sequences are centralized. So talks and discussions and a bit of research. So I think some of them done by my colleague here, Ashraf. Decentralizing your sequences. So that is under works. So get started now. So this is the QR code that I would like to share for those who want to write some contracts, want to write some constructors, want to write events. How do you use it? What are the syntax? This is the part of the page that I would recommend you to go to because I use it sometimes. I forgot how to declare events sometimes, So this, you just go there and you click events. So it's at starknet-by-example.voyager.online. Leave it. A couple of people taking photos. Nice. Put it for a couple of seconds. And the end. Yes, there you go. I also put out a QR code for Starknet on Twitter. Do give them a follow. I don't know if you have time for questions, but yes, otherwise, I'm free and available. Just ask me when you see me, bump me around the area.
Thank you very much, Chyuan. Let's give him a round of applause. I love how self-entertained he is. Every slide he has designed, he has worked on the project, is like seeing his resume. Can we open it up for questions as well? Does anybody have a question? We got one over here. We'll hand the mic over to you. Please introduce your name and your question as well about Starknet.
Hi, this is Wen Hao. Was just wondering what are the costs for Sharp, the shared prover, and also the cost of running a prover for Stone. Open source recently.
That's a very good question. The cost of running a prover, it's very expensive. I don't exactly know how much because I don't run it. I didn't benchmark it. It was recently open source, so I haven't tried it. So, but you have to understand, like the cost of running prover is probably going to be expensive. But we have to understand as well that you only need a couple of people to run the prover for liveness. But you can never lie when you could generate proof. So lying cannot happen on the proving stage. It's just censorship or maybe liveness. So yes, it's definitely not cheap to run a prover.
Thank you for the question. Anybody else? You want to raise your hand and ask? Got one in front here. We got two. Sorry, got two. We'll pass the mic to each of you. Please introduce your name as well as your question.
Hello, I'm Jeffrey. That was a good talk, thanks. You mentioned using Stark outside the context of smart contracts, like in ML. Can you share some more examples of some activity or projects in that space?
Yes, that's a good question. I think there's a project. I can't remember Alexandra, his name of the. I can't remember what's the open source project for ML again. Giza, yes, Giza. It's a open source project on Cairo. That's doing a lot of ML stuff. So do give them a check. Just type Giza Cairo. Or Orion, something like that. Yeah, Orion, Giza, Cairo. There you go. Thank you. Thank you. I forgot. Yeah.
By ML, you mean machine learning, right?
Yes.
Smart MC.
Hello, Chyuan. Thank you very much for your time on the talk. If I'm not mistaken, you can port EVM contract to the ZK environment, correct? So what is the Starknet strategy to onboard more projects and appeal more users for the future?
Thank you for the question. And this is more of a community question. Number one, there was a sunsetted project called WAP, also by my team. So what the WAP does is that you have your Solidity contract, you get to transpile it to a Cairo 0 contract, but it has been sunsetted a couple of reasons. So the strategy right now is to give talks like this, to give workshops like this, try to encourage you, try to let you know, try to advocate you, try to evangelize Starknet, right? Explain to you the benefits so that you understand like why you want to learn Cairo. It has to be the hard way. I cannot like feed you with money and use the right contract. It doesn't work that way, right? You have to understand why you want to learn Cairo and why you want to deploy on Starknet and you love it and then you deploy it. So it's going to be the old school me advocating you, explaining the benefits of you doing it. Yeah. Unfortunately, yeah.
Thank you.
Thank you for the question.
Cairo and Starknet is not EVM compatible, right?
No, Starknet is a chain, Cairo is the language.
Thank you. Any last questions before we close this session? I think that's it. Thank you very much, Chyuan. Let's give him a big round of applause.
Thank you, everyone.
Lovely presentation.